All right, so this is second day of special right triangles. Today's is a 30, 60, 90 triangle, and that's referring to the angles, the degrees of the triangle angles. Um, the theorem is in a 30, 60, 90 triangle, the length of the hypotenuse is twice the length of the shorter leg, and the length of the longer leg is square root 3 times the length of the shorter leg. So, yes. All right, so here, because all three angles are different, all three side lengths are going to be different. So with yesterday, 45, 45, 90, two of the sides were the same and one was different. Here, all three are different and they have a different relationship. But I'm still going to use a tic-tac-toe method. Just a second. And I will give you both of the tic-tac-toe grids for the test. They don't have to be memorized. If you use them, they probably will be memorized by the time you take the test. But this one, so it says the hypotenuse is 2 times or twice. Hypotenuse is twice the length of the shorter leg. Oh, and it says x. We need to change that. I don't like using x. X is too common to use in the table, so make it a. All right? A, and that's the short leg because it's across from 30 degrees. 30 degrees is the smallest angle. So the shortest leg of the triangle is across from the smallest angle. And the hypotenuse is 2 times the shortest leg, which is A. So the hypotenuse is 2A. And the long leg, the one across from 60 degrees, is going to be square root 3 times A, or A square root 3. So the long leg is square root 3 times the length of the short leg. So we have A, 2A, and A square root 3. And that's what I'm going to use in the new tic-tac-toe grid. So the 30, 60, 90, you'll set it up the same kind of way. Degrees, 30, 60, 90. So across from 30 degrees is the short leg, A. And across from 60 degrees is the longer leg, A square root 3. And then the hypotenuse is always across from 90, and that is 2A. And then we'll have to get a starting spot from each problem. Remember, these act like an equal sign. This gives you an equation to solve, and one of these will be filled in from the problem, and the rest of them, this is the answers, or the lengths of the sides of the triangle. That's how you're going to solve for the sides of the triangle, the missing sides. All right. So we're going to solve for x and y and give your answers in simplest radical form. So the first thing I'm going to do is I see 60, I see this is 90 if you have the box. So the other one must be 30 degrees. So a 30, 60, 90. And that is going to set up as A square root 3, 2A. Once you get it set up, then you find what's given to you. I'm given this 5. I have a side length of 5. That looks like the short leg, and it is because it's across from 30 degrees. So that's the short leg. Across from 30, here's 30. So I'm going to fill in the 5. So I have an equation here, A equals 5. And so this is one of the simpler situations. If A is 5, then I can find the long leg because that's A square root 3. And if I know that A is 5, then it's 5 square root 3, right? So that means across from 60, here's 60. This one is the long leg of the triangle is 5 square root 3. And I can find the hypotenuse. Across from 90 is the hypotenuse. It's 2a. So it's 2 times the value of a, and a is 5. So 2 times 5. Which 2 times 5 is 10. So this one, so the hypotenuse has the length of 10. So this is one of the easiest, straightforward ones. Sometimes, depending on what's given, and it depends on what order you go in to solve it. I guess that's the tricky part, is you can't just do exactly the same thing for every problem. It just depends on what's given. Solve for A, however you need to do that. And then once you have A, you just plug it in and simplify if you need to simplify. All right, some more examples. I know I have a 30, 60, 90. Because here's the 90, it's the box. I have 30, so that means the other one must be 60 degrees. So this is going to follow A square root 3, 2A. And then I need something given. 22 is given. I have a side length of 22, so I have to figure out where am I going to put that. Well, 22 is across from 90 degrees, so that makes it the hypotenuse. So that's across from 90 degrees is 22. And that's an equation. 2a equals 22. And I can use that to solve for a by dividing by 2. So a equals 11. And once I find a, I can plug it in to my grid for a. It's 11. And I see that goes with 30 degrees. So that means it's the short leg of the triangle. Across from 30 is the short leg. So x is 11. So all I need to do now is find the long leg. The long leg is across from 60. It's a square root 3. So I'm going to take the 11 times the square root 3. And I can't simplify that really. I'm just plugging in the value of a where there's an a. So y equals 11 square root 3. All right, so on the back, I have more examples. I see I have a 90, I have a 60, so I'm going to label the missing 130 and set up a grid. Make sure you set your grid with big enough boxes to write in. It's a common frustration. Just trying to squeeze numbers into a box is too little. So a square root 3, 2a. And then I need a starting point. So I have to see what am I starting with. 18 square root 3 is across from 90 degrees. So go to 90 degrees and fill it in there. And that gives me an equation. And I can solve for a. 2a equals 18 times the square root of 3. So when I divide by 2, so I can get a by itself, a equals 9 times the square root of 3. And 9 and square root 3 are not, we can't combine those any more than just the way they are. That's all we can do. If we multiplied it out with a calculator, we get a decimal, but I would rather you leave it in simplest radical form because that is more exact. So 9 times the square root of 3, that's all we can do with it, and I see that's a. Well, so that means that a equals 9 times the square root of 3, which is the short leg of the triangle. Across from 30 is right there. So x equals 9 square root 3. And then last, I need the long leg. So I know I take the short leg and multiply it by the square root of 3. So 9 square root 3 is going to go in for a, and then times the square root of 3 again. So I'm going to do this one here. So I have, because it's a square root 3. So a times the square root of 3. And I'm plugging in 9 times square root of 3 for a. So I can multiply the two radicals because they're like terms. Square root 3 times square root 3 be 9 times the square root of 9. And you should recognize the square root of 9 being a perfect square. It's 3. Square root of 9 is 3. So this is 9 times 3. Thank you. So it's 27. So this one is 27. And that's across from 60 because it's the long leg of the triangle. So y equals 27. Okay. Look at another one. 90, 30, so the other one is 60. Split this up too. So 30, 60, 90, a square root 3, 2a. And look for a starting point. I'm given 6 times the square root of 3 as the length of the long leg of the triangle. It is across from 60 degrees. So I go to my table to the 60 degrees and fill in 6 square root of 3. And that's an equation, right? So over to the side, I do a square root 3 equals 6 square root 3. You may already see that a is going to be 6. If you see that, great. If not, you can just solve for a. Because you want to get a by itself, so you divide by the square root of 3. It cancels and then leaves a on the left. And on the right, you have square root of 3 over square root of 3 also, so those cancel. So a equals 6. So we can fill that in our chart. A equals 6. That is across from 30 degrees. So it's the short leg of the triangle. 30 degrees across from there. So x equals 6. And then for the last one, the hypotenuse is 2 times the short leg, so 2a. So it's going to be 2 times whatever the value of a is, and the value of a is 6. So this is 12. So across from 90, because this is 90 degrees, across from 90, that side, y equals 12. So you set up your table. Well, first you identify which kind of triangle you have. Do you have a 30, 60, 90? Do you have a 45, 45, 90? If you have one of those and you're asked for side lengths, set up your table, identify what you have to work with, and then start solving for a. 2 more. 30, 60, 90. A square root 3, 2a. There's my 90, it's the box 60, so I'm going to fill in a 30 for the other missing angle. And I start with 9. I have a side length of 9. The angle across from that side is 60 degrees. So 60 degrees is where I'm going to fill in the 9 and the blank on the row of 60 degrees. And now I have an equation. So I have a square root 3 equals 9. And I need to solve for a. So I'm going to divide by the square root of 3. So a equals 9 over the square root of 3. But if you remember from yesterday, because that seemed a little too easy, right? You can't leave the radical in the bottom. You have to rationalize the denominator. And the shortcut pattern I showed you, because every time you rationalize the denominator, it follows the exact same pattern. Where the number in the top stays there. The numerator doesn't change, 9. The point is you need to get that radical out of the denominator. So move it to the top, whatever it is. This one happens to be a square root 3. It could be a square root 5, square root 2, whatever it is. Move it to the top, but you have to put something in its place. So just put that number without the radical in its place. So just anytime you get a radical in the bottom like this, 9 over the square root 3. So you have a square root in the bottom. Follow this pattern. Move it to the top and rewrite it without the radical on the bottom. That's the shortcut. What you're doing is actually multiplying the top and bottom by the square root 3. And then so on the bottom you have square root 3 times square root 3, which is just 3. This is the one time I tell you you don't have to show work for something. And it's this. So this is A. Oh wait, we're not done. 9 over 3. We can simplify 9 over 3. So that's 3 and 1, right? Because 9 divided by 3 is 3. So A is 3 square root 3. So 3 square root 3. And this is across from 30 degrees. So in my triangle, I find 30 degrees, and across from 30 degrees is A. So 3 square root 3. And then the last one is 2A. So 2A, that's A. Then I just want to multiply it by 2, right? So for this one, 2 times A, and A is 3 square root 3. So you just multiply the like pieces, the 2 times 3, so it's 6. And you can't do anything with square root 3. So 2A is 6 times the square root of 3. It's across from 90. It's the hypotenuse. So y equals 6 times the square root of 3. All right, one more example, and then I'll let you go to your online homework. I actually gave you 2 assignments today, a 45, 45, 90, and a 30, 60, 90. I gave you 2 days for 2 assignments. Yeah. $30, $60, $90, A, A, square root 3, 2A, $30, $90, so $60 up here. I feel like with the $30, $60, $90, it helps to fill in the missing angle. Because sometimes it's the $60 that's missing and sometimes it's the $30. So just fill it in so you can map it out. And then a starting point. is 5. The 5 is across from the 60-degree angle, so that makes it the long leg of the triangle. You can also see that by looking at it, but it's not a good idea to always go by the picture. Maybe it's the triangle is not to scale. So this is 60. Across from that is 5. So that means that a square root 3 equals 5. And so I want to solve that. So I'm going to divide by the square root of 3. So a equals 5 over the square root of 3. But that is bad form, right? That's against the math rules. You cannot have a radical in the bottom. So to rationalize it, to make it a equals 5, I'm going to move the radical to the top, square root 3, and then write the radical without the radical. The, the number inside, the radicand actually is what it's called. We're going to write the radicand by itself, 3. And that one doesn't reduce, so that's it. A equals 5 squared, 3 over 3. And that is across from 30, so that's the short leg. All that's left is the long leg. It's across from 90. Across from 90 is 2a. So I take a and multiply it by 2. So 2 times whatever I said a was, which is 5 square root 3 over 3. All right, so there I have a whole number times a fraction. I feel like it's easier to see how to multiply it if you make the whole number a fraction, which is super easy because you just put it over 1. And now you have 2 fractions. And so you multiply straight across the top, straight across the bottom. So numerator is 2 times 5 square root of 3. Well, you don't do anything with square root of 3. It's just 2 times 5, so that's 10. And you have the square root of 3. And then on the bottom, I have 1 times 3, so that's 3. And 10 over 3 does not reduce. The square root of 3 has a house protecting it. You can't touch that, so it's just 10 square root 3 over 3. And that is the length of the hypotenuse, which is y. And that is special right triangles.